So welcome everyone to Clowder's All Paws conference. We're so happy to have you all join us virtually today from around the world. In the meantime, however, we've got a full day of really great talks and sessions from our presenters today. So thank you all again for joining us, even if we can't be together in person. It is great to see this turnout. And so with that, I will hand it over to our keynote speaker, Kenton McHenry, Associate Director for NCSA Software.
So welcome, everybody. As Katie mentioned, I'm Kenton McHenry. I'm the Director of Software at NCSA and PI of the Clowder CSSI effort that's bringing us here together today. This is our second annual meeting, the first a couple of years ago at PERC. And the goal of these meetings is to bring together those around leveraging and contributing to this software framework called Clowder. And so what I would like to start with is basically a question of why are we here? What is it that we're basically building? What are we contributing to with regards to this framework that we're calling Clowder? Is it about data? And the answer is partially. It is partially about data, but there's a little more to it, right? It's not. There's lots of things that support data management out there. Is it about scientific or research data? Closer, it's definitely about the research aspects of data and doing science with it. But again, there's a little more to it, right? It's more that makes Clowder Clowder. Is it about something on top of the scientific research data? And I would say, yes, it's really more about that plus aspect of it. What on top of the data can you do in addition to the data that you have there? So there's things like the metadata around it. There's things like pre-processing, cleaning of the data, wrangling the data, bringing it together. New processing, analyses done on top of the data, visualizations, sharing and collaborating, allowing other folks to work with you on that data. And then finally, at the end of the day, when your results are in a paper published, publication and archival of that data. So really what we're all about is with regards to supporting this, the scientific research data plus more. This basically what's tied up with computation, these computational aspects and interaction. And all of this for the sake of new science and discovery. So supporting those aspects. So there's a word that's been created some time ago, but it's really starting to take hold these days of scientific gateways. And it really kind of encapsulates what Clowder is trying to do. It's basically it's this idea of there's a lot of, with regards to science today, there's a lot of digital aspects to it. There's a lot of data sets, heterogeneous data sets, large data sets, a lot of tools and computation, advanced algorithms, visualizations that need to be used. And the idea that there's these gateways that are being stood up these days to help the scientific researcher, the users, manage all that, get basically a sort of portal by which they can access all those sophisticated tools and data sets and do things with it, perhaps without being a computer scientist and having a computer science degree where they have to get into the weeds with regards to every aspect of everything there. So the idea of this user-friendly user interface. So where Clowder came from, Clowder kind of started, I think, before the term scientific gateway got coined, was basically about seeing this emerging need across the various efforts that we at the University of Illinois have been supporting through the years. So basically, we're a group of research software engineers supporting scientific efforts around software development. And so through more than several dozen grants and projects across pretty much every agency you could think of, across every scientific domain you could think of, what we saw were common needs around data management, data sharing, plus these computational aspects, these visualization aspects on top of it. And so in order to better support these various activities, rather than kind of doing one-offs per project, we built up this framework, this thing that could be reused per project, that could leverage the past developments contributed to it, and to some degree sustain past developments, once those projects even end, kind of keeping them going to some degree through newer efforts in leveraging past efforts in those. And so this initially was called Medici. I always have a hard time saying that. It was renamed to Clowder some years back and funded initially by the National Archives and Research Administration to kind of stand up this second version called Clowder in going forward. So in terms of scientific data management, as mentioned, there's a wide spectrum of tools out there that support these kinds of things. There's commercial tools such as Box and Dropbox that support the basic aspects of sharing. Then as you go more to the right here, there's more on the aspects of publication and archival with things like Dataverse and DSpace and so forth. Where Clowder lives is kind of in this middle area here. We're in between those with this word called staging up here. And kind of really focused on that idea of that automatic execution of certain processes to kind of help the scientists with their data. So extracting metadata, generating previews to visualize large data sets, things like that analysis aspect. And this paper down here kind of coined that as a term of active curation and social curation. But the idea of basically living data, it's not archival in the sense that it's frozen. It's somewhere in the middle still. We're still being edited, tweaked, changed, processed, and so forth, and cleaned as it's still being used. And so Clowder kind of lives in this space of supporting that largely. And then with regards to kind of supporting many scientific domains, being customizable to every aspect of it. So with regards to things like metadata, being able to upload or modify the schema that's underlying everything and utilize there. And so here's an example with ODM2 being used in this case. Being able to add custom pieces of metadata, such as key value pairs and things like that, as needed. One of the main aspects of Clowder is its extraction bus. And so that's the aspect of it that allows it to do this pre-processing of data, this processing of data as data is ingested in the system. Things automatically start happening, getting fired off. Many of these tools leveraging things like machine learning to do things and find patterns in data and so forth. A few years back, we had this brown dog effort, which tried to really make that aspect a little more shareable between other data management projects, but really build up the extractors and previewers as part of that. And so they touch on all aspects of things from microscopy images to finding pieces of cells and then showing them in a little previewer, allowing for the overlays to display as part of the data. In this case, flood basins or old rivers from old manuscripts, so you can see how they relate to modern day floodplains. The ability to edit documents and then tag pieces of it, assign metadata to a portion of it, or to do things like handwritten recognition and extract handwritten digits and characters from images. The ability to present slideshows for tutorial purposes and educational purposes. You name it. It's videos, tracking people, 3D models, annotating pieces of 3D models. There's a crack here, and it's related to X. Things like that. So the idea of having this library of tools from previous efforts is one of the pluses, but also the ability to easily add new ones to meet custom needs is one of the main aspects of Clowder. And so other aspects of finding trees and the species of trees and LiDAR data, to how tall the plants are growing each day, number of leaves, the greenness of the foliage, things like that are all things that kind of fit in this space. And they're often in the sense of an extractor that extracts this data and a previewer which kind of shows this data to the user, allowing for this user navigation of data in this gateway. And then this new aspect with regards to analyses. This is a growing theme these days with all data management tools. The idea that data is not useful in its own. You got to have the ability to do something with it. And so the idea of placing compute near data so you can actually not have to download data sets and just do stuff right where it resides on the data storage resource, because there's a compute resource right next to it. And so one of the things that's been leveraged in the past, and folks like Rob Cooper are developing further as part of Clowder, is leveraging something that we developed some years back as a National Data Service Workbench, where basically each of the things here is a tool. And what you could do basically is fire off these tools in this portal, this gateway that's Clowder based, and do things like we did for the ARPA-E Terra Ref effort, where basically you could launch, a Jupyter Notebook is a common way of doing analysis these days in the scientific world. Launch one of these things and have the data automatically loaded into that notebook, so you don't have to do anything more other than start working with the data. But you can do that with any number of things that are able to perform some sort of analysis that you need within the data. And then dashboards. One of the other last customizable bits of Clowder is the way it even looks. Change how it looks completely. So we've done many dashboards for various geoscience-related things, agricultural-related things, medical reasons, efforts, where basically it's pulling data and pushing data to a Clowder instance in the background, but it looks completely different. It looks like a map with some overlays. It looks like some spark lines showing you trends in data, you name it. And that's what Clowder is built to do, to basically allow you to support whatever needs are deemed relevant for a particular scientific community, and making it easy to leverage past capabilities that are already there without having to redo them, and just change what needs to be changed. And then lastly, of course, mobile applications. And this one's a case for our 4-seed effort with regards to material science, but there's a number of them floating around as well. Supporting in the field work, for example, to add data set, image data to a repository from the field. So just really quickly, this is an overview of the architecture. You don't need to get into the weeds here, but the idea here is every aspect of it is customizable for any particular scientific application. That was the intent, all the way down to the storage. So whatever storage is available for a given effort, if the grant had something written into it, if we're using AWS, if we're using an on-prem system, being able to leverage that storage, whatever it may be, as well as different computational resources. Again, the cloud or an HPC resource within Exceed, you name it. We've done a number of these things. But to be able to really stitch together a custom gateway for a particular community. So that's one key aspect of it. So that's the idea of supporting, data, scientific data, plus something else, the computational interaction aspects of it that are needed for science. The next key aspect, I would say, is the fact that it's open source, and every aspect of it is open source. So there's a number of these data management tools out there that are open source to some degree as well. But the thing with Clowder is we want people to take it and do what they want with it and not have to worry about really the folks who created it or started it if they don't want to. And this is happening more and more these days. There are a number of presentations today where we didn't really know they existed. So we'll be learning more about them today. And that's what we want to see. And so a key difference also is a number of these tools out there that are developed within science for data management. They tend to have this service-based model where basically they're hosted in one place and you sign up, create an account, get a grant to leverage it, or it's supported by some grant somewhere. So they're centralized and you use them as is. A key drawback to that is it's kind of been resulted in the duplication of many of these key capabilities across different scientific domains, as one supports X domain and one supports Y domain, when really 90% of it could have been supporting all domains. And so that's one of the things that we see as a key feature of Clowder 2, being purely open source, and the idea that anybody could do what they want with it, add what they need to it, and basically supporting, leveraging the 90% of commonality from past efforts in their new effort and adding on top of it as a key aspect to it. So it's got an NCSA license, which is for legacy reasons, it says NCSA, but it's basically a BSD3 license, which pretty much says you could do whatever you want with it. And so over the years, because of this, we've supported a number of efforts in standing up these Clowder instances from all kinds of different scientific domains. One of the older ones, one of the initial ones that helped drive Clowder to what it is now was DataNet Seed. It basically supported science, sustainability research, geoscience, and social science aspects, and it contributed a lot to the core functionality of Clowder's development as well. As mentioned before, we've done some efforts with regards to 3D data, specifically around cultural heritage and the humanities. This is an effort with the European Union at the Cyprus Institute, dealing with some of the artifacts that they had there, and basically annotating pieces of those models and basically creating metadata around them. Material science, you'll hear more from Clara Narstead just after this, I believe, with regards to many of the challenges being dealt with there. Material science data has a lot of metadata associated with it, has a lot of equipment associated with it, with proprietary formats, or perhaps not even access to the web. And so there's challenges in even getting the data and so forth. And so 4Seed is an instance that kind of deals with that in the material science space. With regards to phenomics, we did an effort a couple years back with TerraRef, where basically you have this giant gantry out in Arizona that scans this field of crops growing each day. And the idea is to see how these genetically variant crops manifests the phenomics as they grow through the season, through multiple seasons. And so we set up an effort, an instance of Clowder to support that pipeline, basically. And so this was actually one of our larger instances, supporting terabytes of data a night being transferred over and processed, building stitched images, processing hyperspectral imagery, and so forth. So, and then all the way to industry efforts. We'll hear a presentation from Jerry from Syngenta who's leveraging it there for some of their data management needs as well. And so that's really the idea, is basically this common kind of core framework that's built around the idea of reuse and customizability, so that it can be used wherever it's needed. And so there's also a number of pilot efforts that Clowder's been part of. So just really quickly, a couple of those. The Open Storage Network is this idea of this distributed data fabric across the country, where there are these pods of a petabyte of storage at different universities and connecting them all together. And basically, they just support a basic S3 API, so you just put data into it, just like you would in AWS. And the idea is that kind of part within academia. So basically, each university would have one of these pods. And so one of the pilots we did there was basically showing how Clowder could be stood up to serve as a front face for that kind of thing. So this was part of the IML CZO effort that we did a couple of years back to show how Clowder could easily just fit on top of data stored within such a resource. On the EarthCube side, if you're familiar with that in the geoscience space, they've worked to kind of allow for the crawling of data sets across different repositories using this language called science on schema. It's basically a way of annotating web portals for repositories so that you can see what data is within them, what metadata is within them, and do like Google does with the web and basically crawl them. And so they did a lot of work there with their Council of Data Facilities to enable that and implement that within the various repositories. And then set up this prototype portal called Geocodes that serves as kind of the Google to search across different data sets. One of the things we did as part of that effort, though, towards this, the sustainability of the artifacts that come out of EarthCube was demonstrate how other technologies could then also leverage that and crawl these data sets as well. And so this is the work of Mike Bobak at the University of Illinois, who showed how you could use Clowder to kind of do that as well. So basically, once implemented, you can crawl these data sets and show them from different repositories listed here. And so when you do a query, you're basically searching across different repositories. And so there's been activity across all internationally. And so many of these folks are here today. And this list keeps growing, and I'm pretty sure I'm missing quite a few dots now. But basically, we have supported aspects across literally every scientific domain I can think of, as well as industry and others. Again, leveraging past developments for new developments. And so over the years, we've, as part of different Clowder instances, and these are the ones we just track, processed and ingested hundreds of millions of different data sets as part of Clowder. So that's why we're here. So basically supporting this idea of scientific research data plus this computational aspect. But why else are we here? So as part of that CSSI effort I mentioned, basically what we're interested in with regards to really any scientific investment by the NSF or any agency is longevity, sustainability. And so in the case of Clowder, that's less the sense of the project. Again, there's many projects around it. There's many that are not even affiliated with the University of Illinois. It's the community, specifically an open source community around it, to see that it lives on regardless of any project supporting it. So for those unfamiliar, NSF has this portfolio of investments that it's done with regards to scientific data support, the cyber infrastructure around software and data. Started with the DIBS efforts some years back, and now the CSSIs. And they support a spectrum of things on top of the raw resources that you find within commercial applications with NSF resources like Exceed. And there's middleware type stuff, and then specific user portals, scientific domain portals up here kind of things. And so what we're basically, what's driving this annual meeting and kind of the core of Clowder at the moment is this CSSI that's basically trying to bring together that open source community. So, and address sustainability through that. So with regards to sustainability, if you haven't seen these and you're part of an NSF grant, these are useful reports to have in your back pocket and to take a look at. They basically are the result of a number of workshops with regards to how these efforts funded by NSF sustain themselves long term. They have a number of different models by which to do that. The one that we were in particular looking at as fitting for the case of Clowder was this what's referred to as a mixed business model there. And what it basically entails is, again, there's these science-driven projects that drive things. And that will always be there, but not in the sense of supporting Clowder as Clowder, but supporting some science, whether it be something in geoscience or ecology or so forth. But that's the main driver, not the software itself per se, only with the needs there. And so that's one prong of this. And so another would be institutional support. And so it's things like universities and different educational settings, perhaps. And so I think we'll hear some about that today from folks at Clara at the University of Illinois and Barbara Minsker at Southern Methodist University, who are making some headway there with regards to that. And then there's this idea, as mentioned, as so many of these other data management services do, is a service model where basically there is an option, at least in our case, of a centrally hosted instance for those that don't want to deal with the overhead of standing up an instance. We could provide one and have various tiers of support to go along with that. And so in the past, we've come up with this. All these numbers are out of date, so don't give them too much credence. But the idea is having different tiers where there's perhaps a very basic free instance or a very basic instance with minimal support that's readily available, to more sophisticated instances with a lot of support, perhaps adding degrees of customization along with it as well. And to do that, we're leveraging a resource that'll be supporting that came out of the Brown Dog effort, and to be supporting efforts associated with that, such as Clowder, called Radiant. And basically, it's an on-prem resource to support these research activities. And with the idea that it's similar to commercial resources, so you can easily move back and forth as need be, but the cost is a bit lower for these research activities. It's basically there to support research. And so that's one other aspect of this as well. And then lastly is really that open source community again. And so for this to be viable and to be a living thing, we really want to make that open source aspect of Clowder as viable as possible. And so for many folks, when you think of open source, what you're thinking of is, I'm going to put it in GitHub. That alone does not make a viable open source effort. Many things go to GitHub to die. So software is really a living thing. The basic libraries it's built on change over the years. Needs change over the years. Technologies change over the years. Bugs are found. So it needs to evolve. There needs to be activity around it to support, these new technologies, these new needs as they come up. So somebody somewhere has to do that. And in the open source world, that's done by a community of engaged contributors who do that to make sure that software is always there and living. And that requires governance. It's not just a matter of a free-for-all where people just throw code together. That doesn't work. And so there has to be some structure around that. And so if you look through the Clowder repository, one of the documents you'll see at the very top is this contributing, how to contribute document. And it basically talks about, the basic steps for doing that. Creating an account, creating a clone of the repository, documenting what you are going to develop. And then at the end of the day, everything's based around these idea of pull requests, where basically somebody's going to review what you've done to make sure it fits, to make sure it's good code, is not taken from somewhere else, perhaps, or so forth, and that it runs. And so these code reviews are key to making sure that the Clowder core stays stable. And so how that works is by these folks. Additionally, was Luigi Marini and Rob Cooper, who were the main committers, what are referred to as committers of this open source project. And they had the vision, they had the know-how of its architecture and every aspect of it to kind of see how code fit together from different contributors. Not to mention they did a lot of the coding themselves at the beginning. And so what typically happens over time is you have other contributors who, through their commits to the repository, through their contributions, become knowledgeable enough of the overall framework that they can graduate to become committers themselves. And so Max Burnett was our latest individual to become a committer. Now, the problem here is, if you'll see, I put their organizations here, is they're all at the University of Illinois. And so with regards to viability over the long term, that's not the ideal. But what we would like to see is contributors from many different organizations being part of this. And so that's one of the goals of this annual meeting, is to support the community to become committers of the Clowder framework. So I'm going to skip this little video. We'll put it on YouTube later on, but basically it kind of shows the evolution of Clowder. There's many of these videos out there for different repositories, and you kind of see how it's being put together with these bubbles being different folders and files and stuff like that. And these little people are the committers contributing code. But what you'll see throughout it, as there are more and more as you go through it, there are not as many as we would like. There's still these core folks at the University of Illinois. And many of these little dots here are Luigi and Rob still. And so the idea is for this to be a viable, long-lived thing is to have this done by many people across the world, really. And so one of the steps we've taken towards that is with regards to the governance of Clowder at its highest level. We've established a steering committee made up of the initial stakeholders, the core stakeholders that have really built Clowder. And so we have folks like Clara Narsted, who will speak later. She's the director of CSL at the University of Illinois. Praveen Kumar, who was PI of the IML-CZO effort and the CINet effort that's going on right now. Barbara Minsker at the Southern Methodist University, who's done a lot with us with regards to urban informatics and education, supporting education as well. George Artopoulos at the Cypress Institute with regards to cultural heritage. Anna Lilligenthal, who's building up a new gateway with us for permafrost discovery science aspects. And Noel Falgren at Danforth Center with regards to phenomics. And so the idea is that a lot of the decisions to kind of distribute a lot of the decision making from the core folks at the University of Illinois to the stakeholders themselves as we try to distribute and build out this open source Clowder community. So I'll kind of close there and just kind of introduce a little bit of the agenda that we have in store for you today. So first of all, I'll mention that we'll be hearing from the users themselves. So this is kind of a snapshot of the various presentations we'll be hearing. And one of the things I want to point out is I'm really kind of happy about is at the first Clowder annual meeting, one of the main goals we had was to kind of let each of the users see each other for the first time, because the University of Illinois had for the longest time been at the center of these things. And each of the users would kind of feel the presence of these other efforts going on in the sense of timing, deployments with regards to contributions to the core and so forth like that, so they don't interfere with each other. But they never really understood or saw each other until that annual meeting. But we were kind of aware of them all. Now, a couple of years later, with this next Clowder meeting, I'm happy to say that some of these efforts I don't even know of. And they're basically popping up, basically leveraging this open source software. And this meeting will serve the purpose of allowing me and others at the University of Illinois to also learn about these efforts as well as everybody else. So I'm really happy. And this is the right direction for things to actually be going for an open source effort that this is happening. Also, as part of this, we'll have demonstrations. With regards to new users that might be joining us today. So basically, what is Clowder, how to use it, the main aspects of it, like extractors and previewers, and support for the ever-growing area of artificial intelligence and machine learning. And then one of the things we wanted to do last time, but we didn't have time and agenda to do, but can do this time, are tutorials. And basically getting into the guts of certain aspects of Clowder, with really towards developing that open source community, building the knowledge base out there so that others can become these committers to the core of the Clowder framework and keep it going long term. And then moving forward, so we'll have folks like Luigi talking about where things have gone the past couple of years and where they're going. And then we'll have Nancy Marin from the SGCI talking about science gateways in general and how those kind of activities are sustained. And so I'll close by thanking our organizers. Luigi worked night and day for weeks preparing for this. Luigi, we owe you a debt of gratitude. Katie Nam as well. Her organizational skills have blown me away. Her spreadsheets terrify me, in fact. But I rest easy knowing she's at the helm. Shannon Bradley as well has been contributing to a large degree to this, and Lisa Yanello. You've all done a great job to bring this venue together. And lastly, I want to point out the swag. So if you guys provided an address when you registered, you got a variety of different things. Since this is a virtual conference, we didn't have expensive travel budgets, so we were able to get nice things like stone coasters and these plushies and other things. So you should have received a box with these things in the mail if you provided an address with your registration. And I'll add one other thing. Some of us during the pandemic may have gotten a 3D printer and decided to learn how to design 3D models. So if you go here, you can get these 3D keychains that you can print on a 3D printer as part of your swag collection. So with that, I'll close and hand it back to Katie.